Greetings. In this video, we'll discuss 5 Terraform sample quiz questions and demonstrate them collectively within a single lab. For the lab documents and code, see the GitHub link in the description. Also, see the description to find out how to get your free Terraform Cram Sheet and 5 more sample questions. Let's go. Question 1. Why would a DevOps engineer use Terraform? And remember, we want the best answer here. Answer A, to automate the development of golden images. B, to automate the creation of infrastructure. C, to automate the configuration of applications. And D, to automate the creation of code. I'll give you 3 seconds to pause the video and think about your answer starting now. And the correct answer is B, to automate the creation of infrastructure. That's what we do with Terraform, right? What's the key element in this question? It's Terraform. Terraform is HashiCorp's infrastructure as code tool, otherwise known as IAC. So it deals with building infrastructure, including virtual machines on the cloud and on premises, and lots of other resources such as VPCs, subnets, security groups, users, and much more. Here's the code that I'm working with for this lab, for this sample questions video. And you can see just by looking at it that it's very easy to read and it's also easy to write. So if you go through this lab with me, you'll see that I have a lot of notes here, a lot of comments, and then some code, additional comments, and then we have variables, we have locals, we have a module, we have outputs, and we'll show more of this as we go through the entire video. Now, it's great to know the correct answer, but it's always a good idea to know why the incorrect answers are wrong. So let's go through those as well. To automate the development of golden images. That's not something Terraform does. You might use a tool like Packer or something similar to create your golden images, which are really operating system images that you've built and configured in a perfect way. Now, once you've built those, Terraform can then utilize those and build infrastructure from them. C, to automate the configuration of applications. This is really configuration as code, and you might use a tool like Ansible to do this type of thing. And so, for example, we might use Terraform to build our infrastructure, but then we'll use Ansible to modify what we've built. And perhaps we have virtual machines that we built with Terraform, and we use Ansible to configure applications like web servers and things like that on those virtual machines. And D, to automate the creation of code, we're talking artificial intelligence at this point. And while you can use that in concert with Terraform, that's not what Terraform does by itself. It automates the creation of infrastructure. Excellent. 1 question down. Good work. Let's continue. Question 2. Which command checks your Terraform configuration files for syntax errors without connecting to any provider or backend? A, Terraform plan. B, Terraform init. C, Terraform validate. Or D, Terraform FMT. Once again, I'll give you 3 seconds to pause the video, starting now. And the correct answer is C, Terraform validate. This will check your configuration syntax and your internal consistency within your Terraform code without accessing remote services or the state file, meaning the backend. Okay, so the key elements in this question: checks, and also syntax errors. When you see words like this, we're talking about validation, we're talking about testing, perhaps linting. And so Terraform validate is correct here. But the other key is without connecting to any provider or backends. And other commands will do that, but not Terraform validate. So Terraform validate's a great testing tool to use before you actually apply your infrastructure. Let's show the code once again here. This is our main.tf file, and that's all we have in here aside from a module, with another main.tf, but we'll talk about that in a little bit. We're in the primary file here, the main.tf. And so what I want to do is see if this can get initiated. And so we're going to bring up a terminal. And by the way, I'm working in VS Code here, and it's a great tool to use to work with Terraform. I also have the Terraform extension installed from HashiCorp so that we can get syntax highlighting and the help system. All right, so I go into the terminal and I'm working within the Terraform sample questions directory here, which is where my code is existing. And the first command we're normally going to run is going to be Terraform init. This will initialize our working directory, Terraform sample questions, get it ready to support a backend and a state file, and also download any provider plugins and module information that we might need. So let's run this now, and we'll press enter. And let me go full screen on that terminal. Here's the command I just issued, and it initializes modules. We have a built-in module. We're not grabbing anything from the internet, but we have a built-in module. It initializes that. It initializes the backend where our state file will be stored, and that right now will be stored locally. It also creates a lock file called terraform.lock.hcl. We can see that here. And it also downloads provider plugins if you need any, for example, AWS or Azure. We're not using those because we're just working with a local provider, just so it's easier to do this code and not have to connect out to the internet. But we see down here, Terraform has been successfully initialized. So the directory is ready to go. We now have a .terraform hidden directory here for modules and providers. We also have this lock file that's created, which deals with the platform we're running. Good. Now, this question had to do with Terraform validate, but we don't normally run that until we've done a Terraform init. So now we can run that command. Go to the top here and do a Terraform validate. And I'm using tab completion, which you can do with Terraform and with Bash or whatever shell you're working in. And so we'll do a Terraform validate now. Press enter, and it says success. The configuration is valid. Excellent. That's exactly what you want when you check your code. Now let's go back to the code, and let's say that I made a little mistake here. Let's say that I put in an extra curly brace. Now, when I do that here in VS Code, it automatically puts in an open and closing curly brace for me, guessing that I'm trying to make another block. But it's going to underline that in red. Let's make that a little bit bigger so you can see that. Get rid of the terminal. This is underlined in red here. You can see that here. Also, the file becomes red, the directory becomes red. And so VS Code really lets you know that there is an issue here. And it's expecting another block, but this block has no name. And so that's an issue. Now, sometimes I'll do this kind of thing and I'll be typing quickly and I'll add an extra delimiter like a curly brace or a bracket or something, and I won't realize till afterwards. And so we need to check this type of stuff and make sure before we apply our code that it will validate. So we'll bring back the terminal and we'll run that Terraform validate again. Now, first I'm going to save that file, save that error that I created, run Terraform validate again with an up arrow, and we'll see error argument or block definition required. And it tells you exactly where this is happening. Now, this is built into the help file within Terraform, so it's pretty cool. It tells us exactly what file and what line we have the issue on. And it says an argument or block definition is required here. Well, for example, if we look inside the yellow tab delimiters, our curly braces, that is all part of the Terraform block. For these blue curly braces that I just created, there's no name, there's no block name. And so you can't really have that. And it wouldn't really work this way anyways. I'd have to have something inside of it and so on and so on. So it's not a properly formed block. Now, if we hover on that red line in VS Code, it says the same exact error. And what's happening here is it's utilizing the extension that we have installed, the HashiCorp Terraform extension, and I highly recommend you use that. And it taps into the help file and tells us what the issue is. So let's go ahead and fix that. We'll just get rid of the open and close curly braces, and you'll see that the red line goes away. The error messages are going to go away. We'll save that file, and then we'll go and run that Terraform validate again, and it should say success. And it does. Success. Once again, the configuration is valid. Fantastic. So that was a deliberate syntax error. We understand what we were doing there, but you never know. You might get issues when you're working in Terraform that you really just didn't notice. And so the Terraform validate can really help you with that. Excellent. So Terraform validate was the correct answer, but we also showed how to use Terraform init, which normally comes first. Now, the other answers, Terraform plan, this will actually check for errors. But the primary reason to use Terraform plan is to create your plan, to show the plan in the terminal and or save the plan as a file that you can use later. However, it will connect to the backend, meaning the state file, and it will refresh what it sees. It'll refresh that information, and so that will connect to the backend. The next one, Terraform init, we just showed that, and we said, okay, when you do a Terraform init, that's going to download provider plugins like AWS or Azure or local providers. And so the question was saying without connecting to any provider or backend. So Terraform init is out. However, Terraform init may check some syntax as well. And then finally, we have Terraform FMT, and FMT stands for format. This is a great command. It automatically formats your code so it goes by Terraform conventions, a two-space indent, lined up equal signs, proper tab delimiters for spacing, but it's really just formatting, whereas validate is validating whether you have good code and checking for syntax errors. Okay. Quite often, I'll actually run a Terraform FMT first before a Terraform init because it's just formatting the code. In my video course, I show exactly how to work with these commands and much more. So check out the course at the link in the description. And there you go, another question down. But those first two were easy. Let's dive in a bit deeper. Question 3. A variable is declared without a default value. What happens when you run Terraform apply without providing a value for it? A. Terraform uses an empty string automatically. B. Terraform skips the variable and continues. C. Terraform prompts you interactively for the value. And D. Terraform throws a syntax error during init. Feel free to pause the video. Be back in 3 seconds with the answer. And the correct answer is C. Terraform prompts you interactively for the value. So when no default value is set and no value is provided elsewhere, for example, via a terraform.tfvars file, a command line flag, or an environment variable, then Terraform will prompt interactively at runtime when you do your Terraform apply. This is actually expected behavior. It is not an error. So as you can see here, there's a precedence involved when it comes to variables and their implementation. Know it. We cover it in depth in the video course. Now, the key element in this question is without a default value. What happens when you do a Terraform apply? And without a default value, the variable has no default variable. So let's go back to our code and let's scroll down through here. Now we have our Terraform block. The Terraform block is where we show what providers we're going to use and what version of Terraform we're going to use. Let's go farther down and you'll see 3 variables here. So this is a variable block here, and it's called file name. And essentially what it's going to do is it's going to build a file. And that's really all this Terraform code is doing. It's building a local file within our directory, and it's going to call it hello_terraform.txt. Now, it knows to name the file that because that is the default setting. That's the default value for this variable. Down here, we have CIDR block. That's a different variable block. And we have a default value for that. Our network is going to be 10.0.1.0/24. But the middle variable here, this one that's called file underscore owner, there is no default value. And if there is no default, what'll happen is Terraform will say, okay, it's going to look through a whole precedence. It's going to say, all right, is there a terraform.tfvars file? Are you using a CLI flag? Are you using an environment variable? Is there a default value in the variable block? And if none of those exist, then Terraform will prompt interactively. And that's what's going to happen in this lab. So let's show that. Let's bring up the terminal and let's go ahead and do a Terraform plan. I'm not actually going to apply the infrastructure. We're going to do a Terraform plan to start. Go full screen on this and press enter. And the first thing it does is it says, var.file underscore owner. There's a reference here to a variable that has no default value. And we can't find it anywhere else. So you have to plug it in. And this is interactive. So I have to enter the value. All right, so I'm just going to say Dave. That's going to be the owner, me. Press enter. And then it goes through the plan. Okay, so here's the command I issued, Terraform plan. Here's the var.file owner saying, hey, there's no default value. I entered the value Dave. And then it goes through the entire plan. It says, okay, the plan is to create a local file output, an output file. And this is going to be the content in it based on our variable information and what I plugged in, the name Dave. Now, a lot of the other information won't be known until it's applied, but it does know what the file name will be, hello underscore terraform.txt. We showed that. And finally, it tells you what the plan is. One resource to add. And there's also going to be some outputs. It'll output information in the terminal when it's done. All right, so that is the plan. And we can look at that and say, okay, that is what we want. And you want to do that before you actually do a Terraform apply, because if you do an apply and there's some issues with the code or there's a problem with your planning, you find out about it at the wrong time. So the Terraform plan will check that. It'll do a dry run and check that for you beforehand. Also, you can save this plan for later use, and you would do that with the dash out option. Excellent. Let's look at the incorrect answers. Terraform uses an empty string automatically. No, you're not going to just have empty information. Unless you're sending something to null, you're not going to do that with a variable. So you want to have some type of data there. Terraform skips the variable and continues. No, it's not just going to skip variables. It's going to look at each one, and it's either going to grab the information from somewhere or ask interactively or throw an error. And then it says Terraform throws a syntax error during init, but that's not going to happen because you don't have to have a default value with a variable, right? So, and we saw that. The Terraform init went through just fine. Now, this was a little tougher. Be sure to use the process of elimination when you work through these questions. And most importantly, practice what you see on real systems. Every time you do a question, actually do it on a system. Continue. Question 4. You are calling a child module in your root module. The child module has an output named instance underscore IP. How do you reference that output in your root module? A, var.instance underscore IP. B, output.instance underscore IP. C, local.instance underscore IP. Or D, module.modulename.instance underscore IP. 3 seconds and I'll be back with the answer. And the correct answer is D, module dot and the module name, whatever that is, dot instance underscore IP. To call a module means to include the contents of that module into your configuration with specific values for its input variables. Outputs from child modules are accessed using this syntax: module dot the module name in question, and then the output name. In this case, instance underscore IP. We want to know the IP address of whatever we're installing. So that's the syntax for calling the module. The key elements of the question are child module in your root module. Now, if you just have a set of code in a directory and it's just a main.tf and that's it, then that's just a standard directory of code and it's known as just a root module. However, you may want to use other code and do things with Terraform more than once and have code that's reusable by yourself or by other users or by other systems. And so to do that, we use child modules, separate directories that have code that can be reused. And you can write these yourself, or you can access the huge repository of modules that are available to you at the Terraform registry. So let's actually show this. And we're back at our code here, and this is where we were looking at our variables within our main.tf file. However, if we scroll down further, we'll see a block called module. And the module is just called server. You can call this whatever you want, but that's what we're saying. It's called server. And what we're doing here is we're saying we want to use code that's in a module in a separate directory. And we have the source here. It's modules/server, which we showed briefly before. And then we have one variable, owner equals var.file_owner, which is me. And so that's pointing to this module of code, which I've provided for you. It's in modules server, and it just has its own main.tf. You could use whatever file name you want. Doesn't really make a difference, but this is pretty standard. If we click on that main.tf, this is a separate file, separate main.tf. This is our child module information, and it just consists of a variable block and an output block. That's it. The variable is owner, and this is blank. It has no default value, and that's because, again, we're plugging that in when we actually do the apply for the infrastructure, right? And I'm just going to put in Dave. Now, the module output here, and this is referenced in root as this name, the output is this. And the output block name is server_info in this case. Now, if we look here, it was instance_IP, but that's just an example in the question. In our code, it is server_info. And we have a description, and then we actually have a value, server owned by, and then a variable var.owner, which is going to be Dave, right? That's what it's going to output ultimately. Excellent. So that is an extremely basic example of a module, but it's something that you can do locally without having to do anything with AWS or anybody like that. You can do it locally and it'll cost you nothing and it'll work immediately. Now let's go ahead and actually apply the infrastructure now. Bring up our terminal. And we've already done the Terraform init. We've already done a Terraform validate to check the code. We did a Terraform plan to check that it's going to go through properly. And now it's the moment of truth. Now we're actually going to build the infrastructure. So Terraform apply is the command. We'll maximize the terminal, press enter. And again, just like with the Terraform plan, the first thing it does is it says, hey, we've got that variable that has no value. What are you going to be? Well, I'm going to be Dave. So we'll enter that value now, press enter, and you'll note that it actually shows the entire plan once again. And so you might say, well, Dave, why do the plan previously? Well, in this case, it's actually looking to do the application of the infrastructure. It's looking to apply it. So it's good to do a plan separately just to be safe and also to save the plan for later use if you need it. All right, so again, it's going to create a resource, local file, output underscore file, and it's going to create the content within it. It's just a text file. That's it. So the plan, once again, is one resource to add. It's going to output this information when it's done. And then it says, okay, you have to approve this. So we have to confirm these actions by typing yes. I'm going to do that now. Press enter. And that will instantaneously create the output file. So it creates that less than 1 second. So apply complete, one added, and we get some output information. This comes from our output blocks in Terraform and tells us this information. And so network address is 10.0.1.0. The prefix length, it's a /24. And server info, server owned by Dave. Remember this variable that we were looking at? And output information, well, that's how it created all that for us. If you ever want to see the outputs again later, you could do a Terraform output command and type it correctly. And you'll get all that information again. Now let's take a look at that file created. If we look here, we see hello_terraform.txt. Click on that, and it's this information right here. Owner Dave, CIDR block, network address, prefix length, and server owned by Dave. And a lot of that information went into the outputs as well. Excellent. So we have that text file. Now you can view information about your run and about your infrastructure by accessing the state file. The state file is a source of truth of your infrastructure, and that is here. By default, it's stored locally, and it's stored as terraform.tf state. And if we click on that, you'll see it's a JSON version of our infrastructure and all the values for that infrastructure. In this case, my infrastructure is just a file. It's just a text file. But as you move on, you're going to be working with virtual machines and networking and security and all kinds of stuff. Now, you can also view this information. Instead of looking at the state file, you can use commands. For example, we could do a Terraform state list command. This will list all the resources that have been built and that your state file knows about. In this case, it's only one thing. It's the local file. I'm going to copy that. And if you want to find out details about everything you have, you could do a Terraform state show or a Terraform state show against the actual resource name just to get that one resource. And I'll press enter for that. Maximize the terminal, and you'll see the info, and it looks similar to what's in the state file, but it's in a more human readable format, a little bit easier to read than that JSON that's in the state file. So another good command right there. Excellent. Let's look at the incorrect answers. var.instance_IP. var references input variables declared in the current module. It doesn't reference outputs from child modules, right? So we wanted outputs. We don't want the actual inputs for variables. And then output.instance_IP, that's not valid Terraform syntax. There is no output. And so there's no output reference prefix here. Local.instance_IP, local references local values defined within the same module using a locals block, not child module outputs. Now, if we look at the code, you may have noticed that there was a locals block, and we're going to show more with this a little bit later, but that's not doing anything with the outputs. It's dealing with variables, but not with outputs. Fantastic. So variables and modules are a huge part of the Terraform exam and a very important part of working with Terraform in the field. Know them. Now, this whole sample questions video has been kind of like a crash course on Terraform, and there's so much to know with variables and modules and everything else. So you got to really take it step by step, and my video course can really help you with that. But definitely know variables and modules for the exam and for the field. And last question. You have a variable CIDR block equaling 10.0.1.0/24. Which Terraform function would you use to extract just the network prefix length 24 from this string? And I'll let you just look at the answers instead of trying to fumble through saying what they are. And I'll give you 5 seconds this time to pause the video, and I'll be back in 5 seconds with the correct answer. And the correct answer is C. That's a two-number function with a split. We've got slash, and then we have var.CIDR_block, and then 1. So this will produce the 10.0.1.0 section, and then a comma and 24. That's what that's going to do here. It's going to split that at the slash here. Then the index 1 retrieves 24. Now you have to remember, this is a string of information. It's considered text because it's in double quotes. So it's going to grab 24 as a string, and toNumber will convert that to an actual number as opposed to a string of information. Now you may say, well, why is it grabbing this? We always start with 0 in our indexing in Terraform and in most programming. So 0 would be considered this, the network number, and 1 would be considered the CIDR number, /24. Excellent. So this tests both function composition and list indexing. And these are both common patterns in real Terraform configurations. And this is more advanced stuff. It gets into HashiCorp configuration language, or HCL. It gets into functions. And a hands-on alert, you don't need to know every single option of every function of Terraform for the exam. And there are about 100 built-in functions. The good news is you can't build your own, but you can use any of the functions of the 100 or so that are built into Terraform. However, you should know how to use functions and have a basic idea of each of those functions and what they do, right? So toNumber, you could say, okay, that will extract something from a string and change it into an actual number. The only way to do this is to practice. Make sure that you practice. All right, key elements of the question: the term extract, and also the number 24, the prefix length 24, and this. Those are the keys right here. Let's show this in the code. Now, if we look at the outputs, first of all, in our main.tf, we have an output called prefix length. And that's extracting the prefix length from the CIDR block. We also have an output for network address. So that's extracting the network address from the CIDR block. And we have values for these: local.network address and local.prefix length. Local means it comes from a locals block. And these can be very powerful for you to use when you want to go beyond variables and have information that will stay static and remain the same and access it from anywhere. And so we have our locals block up here, more toward the top, and we have the prefix length. And here exactly is that code that we showed for the answer. toNumber, that's a function which converts the argument or string to a numeric value. And then we have split, and split will split your string of information based on what you choose. In this case, we're choosing to split it here at the slash before the 24. And so the prefix length will be the CIDR block, but it splits it, and it's going with index 1, meaning the second piece of information in that string, the /24. For the network address, for the IP network number, we're just doing a split, and we're doing 0 here. And that means the first index, which is 10.0.1.0. And I kind of have to do this as text because that's not really considered a number because the dots are in between each octet. So we just use split for that one. But if I actually want to display something as a proper number and use that number later, we'll use that two-number format. So that's all done within the locals. And so we have functions in here. This is a function. And then we have a function within a function for this one, all within a locals block. And then we're outputting that information with our output blocks. That's all the output blocks do, is output information after the Terraform apply is finished and based on the values. If you have a locals block, you access it with the name local, similar to variables block. If you have a variable block, you access it with var. Excellent. And if you have a module where you have something you need to output, you have to say module, then the module name, which in this case is server, and then the name of the output. All right. And then if we look down at our file, ultimately, this is the resource. And by the way, I haven't even talked about resource blocks. The resource block is what you're creating, right? That is what you're building. And it could be virtual machines, it could be users, it could be subnets, who knows what. Many, many thousands of different resources out there that you can build based on all the providers. We're just doing this locally, very simply. And this is the resource that's created, an actual local file. This is a name that Terraform uses, local underscore file. And it'll just means that it's going to create a file and you can tell it where to build it. By default, it builds it in our working directory. And we're just using a basic EOT command to write this information here. Now, within this information, we have all these variables shown with the dollar signs. And we have some, actually, we have variables. We have file owner and we have CIDR block. But then we have locals as well, network address and prefix length. And then we have an output from the module with server info, right? So that is our resource. Boom. Excellent. Now, we've already done this, and we had hello terraform.txt, and we have our CIDR block, and it's owned by Dave. But let's show how to override that. And this will kind of tie a lot of things together here. Now, previously, we just did a Terraform apply. Now, let's do a Terraform apply again, but this time I want to use the -var flag. Now, we said before that if there's no variable, you'll get prompted. If there's no value for the variable, you'll get prompted. Unless you have a terraform.tfvars file or a environment variable, or if you have a flag like -var or -var file, because you can have a whole file of variables if you want that you can use within a flag here. We're just doing a single one. And so this is going to be a Terraform apply, but we're overriding this particular variable. The name of the variable is CIDR underscore block, and the value I want to use now, instead of 10.0.1.0/24, is going to be 192.168.0.0/16. Let's press enter for that. And now it's going to say, hey, what's the name of the person who owns this file? Because that variable, the file owner, still has no value. If we had added a value, we wouldn't get asked that, but there's no value on that, so we have to add in the name. This time I'll say Dave2. Press enter. And now you see that we have a replacement going on here. Now, this will differ depending on how you're doing this and what providers you're working with, but we have a replacement at this point. And so instead of Dave, we have Dave2. Instead of this CIDR block, we have this, and so on and so on. Prefix length will go from 24 to 16, and the content will change in the file. But the plan is one to add. This other file is going to go away, and we're going to have our new one. And then we have changes to the outputs that will show in the terminal. This will become this. 24 will become 16. And server owned by Dave will actually become Dave2. And once again, to do any Terraform apply, we have to approve it with a yes, unless you do a -auto approve. More on that in the video course, but we'll press enter for this, apply complete, resources added 1, and we see those new outputs. And now if we look at hello terraform.txt, it already modified up here in my code window, Dave2, new IP network, new CIDR, Dave2. Very good. A little bit more in depth, a lot to talk about with this question, but I think that's good enough for now for this particular video. Let's look at the incorrect answers. Split is not going to work. This will split on periods. And this could be something you want if you want to have each of these numbers extracted and changed from a string to a number if you also used toNumber. But that's just going to split everything, and we'll have a 10, a 0, a 1, a 0 for this variable. In addition, the prefix will be buried. So basically we'd have 10, we'd have 0, we'd have 1, and then we'd have 0/24, which makes very little sense. That buries the prefix in there inside that last element. So it's not going to be cleanly extracted. So that's not correct. Next, substring. Substring will extract characters by position, starting at index 0, which will return 10, because index 0 is the first item within the string. And the 2 tells us it's the first 2 characters of that. So it'll actually be 1, 0. It's not going to give us the prefix here. It's not going to give us the prefix length. So substring is out based on this. And then element actually works on lists. It's not meant for strings like we have here in double quotes. So applying it directly to a string would be completely invalid. All right. Now, one really important thing that I've got to say to you, whenever you're doing testing, whenever you're doing education with Terraform and you're running through your labs, make sure that you destroy the infrastructure. And let's do that now. That's easily done with a Terraform destroy command. And that's actually an alias to Terraform apply -destroy. But if we run this now, it's going to say, well, first of all, you have to know who the owner is. So hopefully you remember what you typed in before. And this is, for me, the overridden variable info, the value, which was Dave2. The first time I did it was Dave. The second time, Dave2. So I'll type in Dave2 here. And then it's going to go through an entire plan once again and tell you that it's going to be destroyed. It's going to destroy this file. And it says the plan 1 to destroy. All the output information will go to null because there will not be any outputs anymore. And once again, we do have to confirm this. So we'll say yes, press enter, and there you go, destroy complete. You can see that the file is gone, 1 resource destroyed. Now, make sure again, whenever you're working with any resources on AWS or Azure or Google or wherever, make sure you destroy them when you're finished practicing with them. Whenever you're doing educational type of work with Terraform, please make sure you destroy them so that you don't get billed any more than you have to. Well, that's it. If you liked the content, then please like the video and subscribe to my channel. And don't forget, your free Terraform Cram Sheet and 5-question quiz is waiting for you in the description. To become a Terraform master, check out my Terraform Complete video course on O'Reilly. And again, that link is in the description as well. So that is it for this video. Thanks for watching. I'm Dave, signing off. Until next time.